equations and then solve by inspection. Give you a chance to write that down. Then we will talk. First of all, under equations, the question is, what is an equation? What's an equation? What's an equation? Question mark. Well, very simply, children, here's your key word here. What word do you see in equation? Equa? Peter? Yeah, it's equal. Okay, an equation is anything that has equal signs in it. In other words, when you did 6 plus 8 equals 14, this really is an equation. You have to have an equal sign in it. If you don't have an equal sign in it, it's not an equation, it's just kind of called an expression. Okay? But what we're doing today is we're looking at equations like this. Okay? Where they have a number you don't know, called an unknown. Known. How does that not look right? Unknown, is that right?
No. Wait.
K-N-O-W-N, unknown?
Oh, that's a W.
Yeah, that's best I can. When we use letters for unknowns, those things are called variables. The letter B is a variable, and it's called a variable because really it can stand for anything. It can be anything. I mean, in this equation it stands for something, but the letter B in another equation could stand for something else. Okay, it can change. Variables can change. Now, the number 6 is not a variable. The number 6 never changes. It stands for the same thing. It stands for 6 or whatever. Anybody know what that's called? The letter B is a variable. Letters are variables. Things that don't change are called constants. They don't change. If something is constant, it doesn't change ever. Okay, don't change. How about the symbol pi? You've seen that before, right? Do you suppose the symbol pi is a constant or a variable? Constant or a variable? Are you taking a stab at it? Anybody? Come on, Jacob.
Variable.
Well, what does pi stand for?
Oh, constant.
Yeah. Pi doesn't change. It always stands for that thing up there. Pi is a constant. It is a constant. So just because something doesn't look like a number doesn't mean that it can't be a constant. Okay. Now, what you're going to do, children, is this. They are going to tell you to solve, still under equation, solve by inspection. And you will only do this for a little bit because it changes a little bit later on. But when it tells you to solve something by inspection, it just means it just wants you to look at it and say the answer. In other words, there's not going to be a lot of work shown other than writing the problem down. It's like, inspection is kind of like doing mentally. Okay? Do it just by looking at it. And if you ask Mrs. Stone for help, she'll go, I can't believe they'll let you do that. But for the first part, for a little while, they're going to have you solve equations just by looking at them. For example, this. W plus 15 equals, what, 17. Okay? If they say to solve that by inspection, you don't have to show any work. You can just go, oh, well, I know that what number when you add to 15 and 17? 2. No work shown. Later on, we'll get to where you have to do show work. That's when they get really complicated because you can't do really hard ones like this. But for right now, they want you to do this. How about this one? 5x equals 30. Now, anytime you have a letter next to a number, that means you're multiplying. Okay, you just say 5 times what number is 30? Sammy? 6. And that's what you have to write on your paper. I don't want just this on your paper. I want you to write the equation and then write the answer. But you don't have to really do any work in between that. How about something a little more complicated? Think about this one. Here's going to be a tough one. 2a minus 1 equals 9. Now for those of you, it might sound a little complicated to you, but let me ask you. This is the question you have to ask. What number, when you multiply it by 2 and then subtract 1 from it, gives you 9? What number, when you multiply it by 2 and then take 1 away from it, gives you 9? And the thing to think about here is you actually kind of have to think backwards. In other words, think about this. What number, when you subtract 1 from it, gives you 9? 10. So 2 times what number gives you 10? A equals 5. Okay? So if you think about doing it backwards, it's actually a little easier. What number, when you subtract 1 from it, gives you 9? 10. This has to be 10, so 2 times what number is 10? That'd be 5. Or this one. How about this one? 20 equals 3f minus 1. Okay, again, rather than thinking about 3 times what number when you subtract 1 from it gives you 20, think about it like this. What number, when you subtract 1 from it, gives you 20? 21. This has to equal 21. So 3 times what number gives you 21? So f has to equal 7. And again, it is a little complicated, and we'll actually, eventually when we actually do the steps, it'll make it a lot easier. But right now, they want you to get kind of the feeling of what you're doing when you do that. How about this one? 3 times what number, when you add 2 to it, gives you, I don't know, let's say 26. 3 times what number, when you add 2 to it, gives you 26. Now, take it apart a little bit here and just say, okay, let's think about this. What number, when I add 2 to it, gives me 26? What number, when you add 2 to it, gives you 26? Gary? 24. So this has to be 24. 3 times what number gives you 24? So x would have to be equal to 8. Take it one step at a time. Do that there. And then one more piece of notepaper.